Move on in chapter 1, what's going to happen now is we're going to start working with equations. And today's learning goal is I can solve one-step equations. In other words, we're only going to take one step of work in one variable using addition or subtraction. Okay? So what we're going to do is we're going to, first of all, we're going to talk about the vocabulary, which we've already talked about some of this vocabulary. You've already done some of it. So let's see how well we can do with our vocabulary words, okay? So what's equation? What's the definition of an equation? You can even give it in your own words if, you know. No, an equation's not the answer to a problem. Blake?
A mathematical statement that two expressions equal.
Okay, a mathematical statement, so it's kind of like a math sentence. Okay, so let's put that, let's just say a math statement. We could shorten up the word mathematical, okay? A math statement that two expressions are equal, okay? So a math statement where we have set one expression equal to another. Two expressions are equal. Remember what we talked about? We said an equation has to have what in it? What sign does an equation have to have in it? No, it doesn't have to have a plus sign. It has to have an equal sign. Yeah, it has to have an equal sign in it. Okay? So give me an example then of an equation that we could use as an example for a visual course. Taylor.
4 minus 5 equals 1.
4 minus 5 actually does not equal 1, but it equals negative 1. Yeah. So the expression 4 minus 5 is the same as negative 1. They are equal to each other. Okay? Somebody give me an equation that happens to have an algebraic expression on one side. In other words, when we look at it, it is telling us that this expression is the same as that, even though, you know what, it may not even look like it. Can anybody come up with an algebraic expression on one side and a constant on the other? Okay, I'll do it for you. X plus 3 equals 6. That equation is saying x plus 3 is the same as 6. You can count on it. Okay, what is a solution of an equation then? What's that? What are they looking for? They ask us to find the solution of an equation. Blake?
The value of the variable that makes the equation true.
Yeah, the value for the variable that makes the equation true. So the value for the variable that makes the equation true. The value for the variable that makes the equation true. So in other words, if the equation has a variable in it somewhere, we're trying to figure out what value, when it's substituted back in there, would still hold the equality, would still be a true statement. So, can anybody give me an example? How about that one up there, that equation x plus 3 equals 6? Anybody think they know what the solution to that one is? 3. Yeah. So, the solution, the value for the variable that makes the equation true, we would say x equals 3. That's the solution. Are there any other solutions for that particular equation? X plus 3 equals 6. Are there any other values for x that we could put in there and it would still make the equation true? Because every now and then there happen to be more than one. Is this one, x plus 3 equals 6, does it have more than one solution, do you think?
6 plus x equals 3. That work?
What did you say?
6 plus x equals 3.
6 plus, no, now we've changed the equation so that, so if we did that equation, x plus 6 equals 3, now we have the same equation. You know, we have a different equation which would have a different solution. Okay, that's just kind of like renaming it. So yeah, is it what I'm asking? This is the question I'm asking. Does the equation x plus 3 equals 6 have any other solutions? Are there any other values we can put into that equation that would make the equation true? Let's try something. What if we put 4 in there? Is 4 plus 3 6? 2 plus 3, is that 6? 2 plus 3? 2 times 3 is 6, but not 2 plus 3, right? How about negative 3? How about the opposite of 3? What if we put negative 3 in? What's negative 3 plus 3? Is that 6?
0.
That's 0. So I'm thinking there's probably only one solution for that, isn't there? So when we have a solution, we can state this is what the value of the variable can actually be. Okay, what does isolate the variable mean? Because here's what they tell you to do. When you're solving an equation, they say isolate the variable. Do what? Move it to one side, or in other words, get it by itself, right? We need that variable to be by itself. So let's say get the variable on one side by itself. Get the variable by itself on one side. Get the variable. I wrote it. Oh, get the variable on one side. I left the word on out, didn't I? On one side. Let's get that word on in there so it makes sense. Get the variable on one side by itself. $1 million question for you. Anybody want $1 million? No? Okay. $1 million question for you. Does it matter which side that variable's on? By itself? Does it have to be on the left side? No. So then you're saying if it doesn't have to be on the left side, it's okay if it's on the right side instead? It can be on both sides. At the same time? No. On one side or the other, right? Yeah. Because it doesn't matter when the equal sign is there, it's saying this is the same as that no matter what, right? So if you change them around, does it change the equality?
No.
So in other words, if I say to you 2 plus 1 is 3, is that true? It's 2 plus 1, 3. If I change it around and I say 3 equals 2 plus 1, is that still true?
Yep.
Does 3 equal 2 plus 1? It doesn't matter which side the variable ends up on by itself, it just has to make sure it's over by itself. So let's show a couple of examples. We could say y equals, I don't know, 4. Now the variable's by itself on the left side. Or we could say, how about 5 equals n? That would still be a solution. The variable's by itself. Okay, so get the variable alone. Isolate it. Here it is isolated. Here it is isolated. It's by itself. Okay. Keep the equation balanced. What's that mean? Give it anti-dizziness pills? So it's got good balance? How do you keep an equation balanced? Keep the equation balanced. Preston?
Perform the same operation on both sides.
Yeah. Perform the same operation on both sides. Perform the same operation on both sides. Perform the same operation on both sides. It's kind of like, how many of you in here have siblings? Anybody got a sibling? Oh, most of us do, yeah. All of us do. Okay, well then, you know, what happens if somebody says, you and your sibling are standing there, and somebody says, I'm gonna give you both, you know, I'm gonna give you $5. So he hands you $5. And then your sibling says, how about me? And they say, no, that's not what would be the word that would come out? That's not fair. It's kind of like when you're not keeping the equation balanced, it's like you're not being fair. If you do it to one side and you don't do it to the other side, you're not being fair. If you don't give $5 to both of you, one of you is going to claim unfairness going on, and you're not going to let that happen most likely. So when you think of it, you can kind of think of like, are we being fair? Are we doing the same thing to both? Treating the same. So give me an example. Let's see. I will just give you one. How about if I have the equation x plus 6 equals 10? If I wanted to isolate the variable, what I'd have to do is I'd have to get rid of that 6. So I would have to get rid of that 6, I would say, I'm going to take that 6 away. But now if I'm going to take 6 away from one side, what do I have to do? Take 6 away from the other side, don't I? That's called playing fair. Keeping the equation balanced. Okay, and our last word here that we want to talk, vocab that we want to talk about are inverse operations. I don't think you're going to find them in that lesson. Does anybody remember the definition for inverse operations? What does that mean? Operations that what? That undo each other. Yeah. Operations that undo each other. What's the undoing of giving? Taking. What's the undoing of going up? Going back down. Okay. So can you give me some, can you tell me what the inverse operation of adding is? What undoes adding? Subtraction. Addition. Oh, I said that kind of the wrong way. Addition undoes subtraction. So if something's being subtracted, we would add it back in to undo it. If something's being subtracted, or something's being added now, we would say, well, addition will undo that. They undo each other, don't they? So if we're subtracting, to undo that, we can add it back in. Same amount back in. Right? It has to be the same amount, though, to undo it. And vice versa. So addition and subtraction are inverse operations. They undo each other. Okay, let's go do some practice then on the back side. Anybody have any concerns on this side before we move on? Okay, now is when you're going to need your book. Okay, what's the first objective in this lesson? In other words, what do they want us to deal with first here? What are we going to... So by example 1, that's where you would find it. Example 1 in lesson 1.2. What's the first objective? It's in blue letters. Yeah, solving equations by addition. In other words, what are we practicing here? We're solving equations by addition. In other words, it's pretty much telling us that's the inverse operation we're going to need to use. Well, we're going to go to the check it out problems that are below example 1. So at the bottom of page 17, everybody locate them. The check it out problems below example 1, not example 1, but below it. Check it out problems, bottom of page 17. How many are there? 3. 1A, 1B, 1C. I've already written down 1A for us. Okay, so it is the equation n minus 3 2/10 equals 5 6/10. We need to solve that equation. Remember, we're solving. We need to solve that equation. What are we going to have to do? Add what? To both sides. Yeah, we need to keep the equation balanced. We need to use the inverse operation, which is addition, so we're gonna add 3 2/10 to both sides. We gotta play fair. If you just do it on the right side, are you playing fair? No. No. Gotta do it to both sides. Because what happens over on this side? What actually ended up happening now? What's by itself on the left side? The n is now by itself. This, subtracting 3 2/10 and then adding it back, just undid it. It became nothing. It took care of each other. So now the n is by itself, and we don't need a calculator. What's 5 6/10 plus 3 2/10? 8 8/10. And bring down our equal sign. What is this called again? What's this? N equals 8.8, 8 8/10. What is that? Which of those 4 things, which of those vocabulary words in the front is that? What did we just find? What's that called?
Adding, subtracting, solution.
What did we just find? The solution, yeah. I want you to write that. I want you to circle n equals 8 8/10. We just found the solution. We found the one and only value that makes that equation true. 8 8/10. Okay, it's asking us to do check problems in our homework today. And I need to start introducing check problems. Trust me, I really don't want to, because here's what ends up happening. You need to hear me on this. Everybody, tune in right now. Don't be working your head right now. You need to tune in and hear me on this. Check problems are, the reason we do check problems is because we want to make sure our solution does make it true. We are not solving right now. We are not doing the same thing to both sides to get keep the equation balanced. We are evaluating any expressions in that. So it's kind of like we're evaluating. Remember our evaluating practice that we did? We substitute in for the variable and we evaluate. We find its value. So what we're going to do in a check problem is we're going to take our solution and we're going to make this like, we're going to take our equation and we're going to take our solution and we're going to substitute it in place of the variable. So go ahead and do this on your papers. We are doing a check problem. We do not need to solve this. We've already solved it. We are evaluating the left side where the variable is and seeing if our evaluation, our value, turns out to be the same as the other side. So we work down. We don't do this like add to both sides or subtract from both sides. We just say, what is 8 8/10 take away 3.2? So if you had $8.80 and you gave $3.20 away, how much money would you have left? $5.60, also known as 5.6, right? Now, you actually need to do the math. You need to do the arithmetic, work your way down, and then bring this down and say, well, there's nothing I can do here, so I'll bring that down. And then you say, do I have a true statement? Is this true? Is 5.6 the same as 5.6? Is it check? Yeah. 8.8 made the equation true. This is a true statement. So notice the difference. I want you right now to observe the difference between solving and checking on your papers. Notice the difference because I don't want that to be confusing, but I do want you to do check problems in your homework. Okay, anybody have concerns? Okay, write down the equation for 1b that we need to solve. By 1b, write down the equation from the book that we need to solve. Anybody want to offer up what they think we should do? I think we should do in this problem to get it solved. Subtract 6. We always want to look on the side where the variable is. Which side is the variable on? Which side is it on? The right side. So what's happening on the right side? It says k, the variable, has a 6 being subtracted from it. What would undo subtracting 6 look like? Add 6, wouldn't it? Yeah, so we're going to add 6 to both sides. And notice, I like to do a line down, kind of divide the two sides up. Well, now let's just keep working from left to right. What is a negative 6 plus 6? 0, right? Yeah. Is 0 legitimate? Can it be an answer? What do you think? Is
No.
0 on the number line? Yeah, it's legit. And then what's left over on the right side? What do we have? 0. This cancels out, but what's really left? K. What's this called? K is by itself. It got isolated. This is our solution. This is our solution. So we're saying, okay, I get to be done with this one. I get to circle it and say K is equal to 0. It's the only value that should make this equation true. So when we do a check problem, does the check problem look like a solving problem? No. We're going to write the equation down like it was. Negative 6 equals K minus 6, but this time we're going to make a T. Like that. Which side can be evaluated? The left side or the right side? The right side can be evaluated. So we're going to leave the left side like it is. We're just going to bring it down like it is. And we're going to substitute what we think K, what the solution is. We're checking to see if it works. So we put 0 in for K because that's what we got. And then we work down here and we say, what is 0 take away 6? In other words, if the temperature outside is at 0 and the temp drops 6 degrees, where does it end up at? Negative 6. Negative 6. This side becomes negative 6. Bring our equal sign down. There's no evaluating to do there, so we just bring it down. And what should happen if we want to keep that equal sign there? One side should be the same as the other, is it? So we say it checks. We're feeling good. Say I can move on to the next problem. Okay, you go ahead and try the next one on your own. The whole works. Do it. Solve it. Check it. What will it look like in your homework? You get a stamp tomorrow. When you've done both parts, both the solving and the checking, you can look up at the board and see if you and I agree. This is your solving. That's your check. So you solve the check. You've only done the solving. Always circle your solution box. It's something to make it stand out, be like, this is my answer. And then the checking is just, like, that's just an extra part of saying, how I'm checking to see if my answer makes it work, makes it true. Let me caution you about something. Here's what students do when they do check problems. They do the substitution step, and then they automatically just write down, because this one has 16 by itself on one side, they just automatically write down 16 equals 16 checks. They really don't take the time to make sure that the expression they had, 25 minus 9, really does equal 16. I will see some of the craziest papers, like maybe they had to bring down a 4, and here's what the problem was. They had to substitute in a 1. So here's our equation: x minus 5. They got 1 for an answer, so they substituted 1 in, and they put a 4 here, and they said it checked. Is 1 minus 5 4? No. What is 1 minus 5? Negative 4. So would they have the right solution? No. This means, uh-oh, something went wrong. I don't have a true statement. 4 does not equal 4. That's not true. So it does not check. I better go back and rework the problem. That's why we do check problems, okay? Okay, get out a sheet of loose leaf paper.